Here we're going to look at topic 28, example 2, graph exponential functions. So we're told a network administrator uses the function f of x equals 5 raised to the x power to model the number of computers a virus spread to after x hours. If there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network? Okay, so the first thing I'm going to look at is this f of x equals 5 raised to the x power. And to fill in my chart, rather than do this by hand, I'm going to use the graphing calculator. So y equals, I'm going to type in 5 raised to the x power. And then I'm going to go to second and then hit the table or the graph key here. And now I have my chart or my table. Okay, so the table on the example starts with 0. So 0 matches up with 1. 1 would be 5. 2 and 25, 3, 125, 4, 625, and 5 goes with 3,125. Okay, so now I'm going to plot these points. Just having the graph is going to help me interpret this. Be careful, your y values, each little box increases by 100. So the 0.01 is going to be really close to the origin. So we're just going to put that all the way down there. And we're just looking for a sketch here. Does not have to be perfect. 1.5 also going to be incredibly low. 225, we can start kind of bring that number up a little bit. Again, we're looking for sketches. 3, 125. So now our graph is increasing just a bit more or a bit faster. 4, 625. That jumps up quite quickly. So we'll say somewhere about there. And then 5 goes with 3,125. That's off of our graph. So we're going to connect these dots. And we're going to do that the best we can. So this is going to go up this way, and then it's going to increase at a very sharp rate. Now, I'm not going to put an arrow, so I would not draw the rest of this graph going left here, because we're talking a number of hours. We won't have negative hours in this case. So I'm not going to put an arrow. I'm going to start at 0. Okay, so we have our chart or our table, and we have our graph. So now we want to determine if there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network. So at 1,000, my graph here looks like it's somewhere between 4 and 5. Now remember, this is drawn by hand, so this is not going to be perfectly accurate. So we don't really know whether that's going to be 4.1 or 4.5 or 4.9. Right now, all we know is that it's going to hit 1,000 somewhere between 4 and 5 hours. However, what I can do, since I have access to a graphing calculator here, is I can make this table a little more specific, and I can find a more accurate answer. We might not find the exact answer, but we can find a more accurate answer rather than just saying between 4 and 5 hours. So what I'm going to do is I'm going to change the setup of my table, and I'm going to hit second, and then the window key also has table setup, so I'm going to click that. So again, you would hit second and then table setup. Now the table start is where you want the table to actually start at. So let's say I put in a 5 here. If I go to my table, notice that it starts at 5. If I go back to the table setup and I put in 100, notice if I go to my table, it starts at 100. Okay, so that's always going to be pretty useful, so you don't have to scroll forever. My table setup, I know my solution or my about approximation is going to be between 4 and 5. So I'm going to start at table start of 4. And then my change in the table, that's the x value and how much I want it to increase with each time. So if I leave it as a 1 and I go to my table, it goes up 4, 5, 6, 7, 8, 9, 10. If I go to my table setup and I change the table to say a 10, if I go to my table, notice how the numbers go up by 10 this time. So what we're going to do is, because we want this to be a little bit more specific than just 4, 5, 6, 7, we're going to change this to, let's say, 0.1. If I go to my table, now I have 4, 4.1, 4.2, 4.3, and so on. So this gives me more accurate answers. And if I go to 4.3, that matches up with about 1012, which is close enough to the 1,000 computers that we're looking at. So a more accurate answer, I would say about or approximately 4.3 hours. Oops. Now you could get more specific than that. Instead of just going to the tenths place, you could go to the hundredths, but 4.3 hours for this question is good enough. So about how many hours will it take for the virus to spread to the entire network? It's going to be about 4.3 hours. The main takeaway from this example, what you want to be able to do is you want to be able to plot something on the y equals, type in your function. You want to make sure that you can look at a graph. You can look at a table, and particularly for this example, you want to make sure that you can do the second table setup and you can change your table start and your change in the table values. All right, if you can start to really understand these two things here, it's going to make finding your answers on the table significantly easier. That's it for this one. If you looked at the try it, they're asking you how long will it take for the virus to spread to 50,000 computers. What you should do is scroll down until you have a Y value of 50,000. So you keep going, and that looks like it would be somewhere between 6.7 and 6.8 hours. Okay, so in this area here. But that's it for that one. Hopefully that makes sense.